Okay, we have section 10.4, deals with the inscribed angles. So here's our main ideas and vocab. So when you're talking about an inscribed angle, that's an angle that has its vertex on the circle and its sides are made up of chords. So here you go, there's your vertex B, it's on the circle, so AB and BC are chords of the circle, they form the sides. And this arc here, ADC, is referred to as intercepted. So that means that it's meets the angle. So the intercepted arc is held within the angle that's formed. So here we have theorem 10.5. If an angle is inscribed in a circle, then the measure of the angle is 1/2 the measure of its arc. Or the reverse, the measure of the arc is twice the measure of the angle. So you have these two equations. So the angle is equal to 1/2 the arc's value, or twice the angle is equal to the arc. So depending on which one you have, you can always find the other one. So the angle is always the smaller of the two. Alright, so here we have example 1. Circle O, arc AB is 140. Arc BC is 100. And AD is equal to DC. Find the measures of 1, 2, and 3. So before I can do anything, I need to find the measures of arc CD and arc AD. So these two guys together make up 240, which means that the other two together have to make up 120 degrees. And if they're equal to each other, that means they both have to be 60. So obviously this figure not drawn to scale means that arc is much larger than that arc. So measure angle 1, measure angle 2, measure angle 3. So angle 1 here, so its intercepted arc is AD, and the measure of the angle is always half the measure of the arc. So 1/2 of 60 is 30. For angle 2, it's intersecting CD, which is also 60, so this guy is also 1/2 of 60, or 30. And angle 3 intersects this arc here, so there's angle 3, intersects 100, so it's half of 100, or 50. Alright, so here we have 10.6, which just states that if two angles intercept the same arc, they must be congruent. Or if they intercept congruent arcs, they must be congruent. So here, angle DAC and angle DBC have to be congruent because they both connect to arc CD. So two different angles connecting to the same arc. Over here, angle FAE and CBD have to be congruent because they are with congruent arcs. Pages apart. Alright, so example 2. A and B are on a circle so that the measure of arc AB is 60. So A and B are on a circle, the measure of that arc is 60 degrees. Point D is somewhere on the circle, so it does not coincide with A or B, which means it does not lie on top of A or B. So like D is somewhere over here. What is the probability that DAB is equal to 30? Now, if D is where I drew here, is guaranteed to be equal to 30 because the angles have the intercepted arc. But it could also have, so here's A, here's B, and I can put actually D in the middle. And in that case, if this arc here is 60, this other arc is 300. And in this case, ADB is equal to 150, or half of the 300. So here, if this is 60, this is 300, angle D has to be somewhere in this 300 degrees for that to be true. So the probability is 300 out of 360. Oh, should have brought my calculator. That's 30 out of 36, divided by 3. That's 10 out of 12, divided by 2. That's 5 out of 6. That would be your answer. Okay, so down here, 10.7. If the inscribed angle of a triangle intercepts a semicircle, the angle is a right angle. So here, arc ADC is a semicircle, so angle B must be a right angle because this value is 180 since it's a semicircle, and so the angle is half of that, or 90 degrees. So you got example 3 here. So you got two triangles, ABD, so that's the top one, and ADE, the bottom one, are both inscribed with arc AB congruent to arc BD. Find the measures of 1, 2, if 1 is that and 2 is that. So if these two are equal, that one is 90 and that was 90 because AFD is the diameter, so that's a semicircle, so it's 180 total. And if these two are equal to each other, they have to both be 90, which means angle 3 is 45 and angle 4 is 45. Angle B here is a right angle because it's opposite the diameter. Same thing for angle E, also opposite the diameter. Now since this is a triangle, angle 1 plus angle 2, 2 plus 90 has to be equal to 180 degrees. Angle 1 is 12x minus 8. Angle 2 is 3x plus 8 plus 90 is equal to 180. So that's 15x's total. The 8's cancel each other, leaving just the 90 equals 180. 15x, subtract the 90 across, divide 90 by 15 is going to be 6. So x is 6. So measure angle 1 is actually equal to 12 times 6 minus 8. That's 72 minus 8 is 64. And measure angle 2 is equal to 3 times 6 plus 8, which that's 18 plus 8 is 26. And if I did my math right, these two should add up to 90 because angle 1 plus angle 2 plus 90. So these two together have to be 90 degrees, which they do. So there you go. There's angle 1 and angle 2. Alright, so angle 4, ABCD is inscribed in circle P. If measure angle B is equal to 80, so that one is 80 degrees, and angle C is 40 degrees, find A and find D. Now there's actually a really fast trick to do this, the theorem is actually on the other page, is if you have a quadrilateral, so 4 sides, this only works for a 4-sided figure, drawn inside a circle, opposite corners are supplementary, which means they have to add to 180 degrees. So D plus B has to be 180. So I can say this, angle D plus angle B has to be 180. And the same thing is true for the AC pair. Angle A plus angle C also has to be 180. So if angle B is 80, angle D must be, off the bottom, must be 100. And over here, angle A plus 40, which means that angle A must be 140, subtract across. So there's your angle A, there's your angle D. I believe the last slide here is the theorem about that. So, yep, there you go. 10.8, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So that means they have to add to, remember, supplementary means adds to 180. And that is the end of the section.